Hello, this is section 6.2 applications of the normal distribution. The standard normal distribution curves can be used to solve many practical problems. Assume the variable presents here are all normal or approximately normal distributed. First, we transform the original variable to standard normal distribution variable using the formula for z equal to value minus mean over standard deviation, which is the same as z equal to x minus mu over sigma. So rounding the result to the two decimal places. So in order to find the area under any normal curve, number one, draw the normal curve and shade the desired area. Number two, convert to the value of x to the z value using the formula, and then find the corresponding area using a table, calculator, or software, but we are using table. Liters of the blood. An adult has on average 5.2 liter of the blood, and assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of the people who has more than 5.4 liters of the blood in their system. So number one, draw the normal curve and then shade the desired area. So this is a normal curve. Okay. And then on the number line, we are using the standard the normal distribution. So we put the 0 as a mean, which is that, and then we put the 1 standard deviation, 2 and 3 standard deviation on the left, -1, -2, -3. So this one says about the 5.2, so which means we are converting it. So under the curve, which is this, so mean was 5.2, which is the same as we can convert it as a 0, and then the standard deviation is 0.3. So one standard deviation, you adding 0.3 here, so 5.5, and then 5.8, and then 6.1 as a 3 standard deviation. On the left side, subtract 3.3, I got 4.9, 0.3, 4.6, 0.3, subtract 0.3, 4.3. And then, so in order to use that, we have to convert it. So do the conversion. So P of, which is this is x, is greater than and 5.4, because it says more than 5.4. And then in order to convert to the z value, so we have the probability of z of, and then formula was, we are using these formulas. So x minus mu, which is 5.2, and divided by sigma, which is 0.3. And then if you simplify that, you get the z is greater than 0.67. But the area that the table shows us is always less than, so we have to convert it. So we have to change it as a 1 minus P of z is less than and 0.67. Which is, if you use a table, so let me show you how to use a table. So I need to go back to the formula. And then on the formula, I have to find we have to use table E. Okay, table E. And then this z-score we have is a 0.67, which is a positive. So go to the positive z-score. And then our z-score was 0.67, right? Which means we are looking for the area. This is 0 in the middle, 0.67 here. We are looking for the area of this one, but area of the in here actually give the area of on the left, this shade area. So in order to find the shade on the right, we subtract from the 1. So I need to find the 0.67. So x is a 0 right here, point, and then 6, 7. 6 is right here, and then I go to the 7, which is I see the 0.7486. So that's the numbers I'm using. So go back to the 6.2. So this becomes 1 minus 0.7486, which is subtract from 1 is 0.2514. So this is the area of the shade, which is right here. This is the area of the shade, which is that's the probability is given to us, which means 25.14% of the adults have a greater than 5.4 liters of the blood in their stream. All right, let's look at step 3. Yeah, we have to conclude that with us. So find the corresponding area, which is the area was 0.2514, which is we can say that as therefore the 25.14% of the others have greater than 5.4 liters of blood in their stream. Okay, let's do the next problem. Monthly mortgage payment. Average monthly mortgage payment, including the principal and interest, should be okay. So there's a typo error here. Should be is $982 in the United States. If the standard deviation is approximately 180, the payments are approximately normally distributed. Find the probability that a random selected monthly payment more than 1,000 be more than 1475, and then between the 800 and 1150. Okay, so first one, so the mean is 982, and then we are looking for the probability that is more than $1,000. It's about here. So we're looking for this one. For the B is we are looking for the middle on the mean is 982, and then it's more than 1,000. So this is the 1,000, and then it's gonna be 1475. So we're looking for how much of the area of this one. And then 0 is here, so about 800 is here, and then the 1150 is right here about, and then we are looking for the areas on here. So we are using the formula, which is this, okay, in order to find the z. So P of z is greater. X is a 1,000 minus mu is 982. Standard deviation was 180. And then when you simplify that, we just need to find the z square here. So z is 1,000 minus 982 over 180. And then z squared becomes 18 over 180, which is a 0.10. So that's a z square. For the second one, z square was 1475 minus 982 divided by 180. And that becomes 493 over 180, which is 2.74. And for the third one, we have to find the 2z score. So one is going to be used 800 minus 982 divided by 180, which is negative 182 over 180. It's about negative 1.01. And then another z score is 1150 minus 982 over 180, negative 168 over 180 over 0.93. Excuse me. All right, so now find the appropriate area. So now I have to use the P of the z we converted as 0.10, which is we can find the area of the greater than z, so we have to use the 1 minus P of z is less than 0.10, which is become 1 minus 0.5398. that is 0.4602. For the second one, so P of now the Z is greater than 2.74, which is same as 1 minus P of Z is less than 2.74. So 1 minus 0.9969, 0.0031. For this one, we have to find the P of the Z was negative 1.01, and Z is between the 0.93. So in order to find that, we need to find the area Z less than 0.93 and subtract P of Z is less than negative 1.01, and then you get the 0.8238 and subtract the 0.1562, which become 0.6676. Okay, so we have to use those formula. Okay, the formula for the finding the value of the normal value of x. So this is actually that you just need to solve for x here. Okay, so in order to solve for x, you need to multiply by sigma both sides, which is you got the z sigma, which is x minus mu, and then adding the mu both sides. And then you get the z sigma plus mu equal to dx. If you reverse it, x equal to z sigma plus mu. So yeah, it's from the finding a z-score. Okay, so we can use this formula. So finding a data values for the specific probability. So draw a normal curve and shade the desired area that represents the probability, proportion, or percentile. Find the z-value corresponding to the desired area from the table, calculator or computer software, and then calculate the x values using the formula for this one. So let's get the problem. So police academy qualification. So to qualify for the police academy, candidates must score in the top 10% on a general ability test. Assume the test score are normally distributed and the test has a mean of the 200 and standard deviation of the 20. Find the lowest possible score to qualify. So in step 1, draw a normal distribution curve and shade the right hand 10% of the area. So in order to do that, so that I can start it from here. So which is the number line. And then you put the nicely normal curve, which is a normal distribution. And then the mean is actually 200. And then the standard deviation 20, so 220, 240, and about 260. And then left hand side 180, 160, and 140. All right, so that's the actually normal distribution curve. And then the shade the right hand 10% of the area. So right hand 10% of the area, I want to say about here. Okay. All right, let's look at the, so yeah, we have already here. So I want to just make that as mean was 200, 220, 240, and 260 on the right, 180, 160, and 140 on the left. So step 2, the area on the left of the 0.1 shaded on the right is 1 minus 0.1. Okay, so in the place of here, so we are looking for the about the 10%, which is same as 0.1. So we are looking for the z-score this time. We need to convert it in. Okay, so which means this the white region will be the 90%, which is 0.9. So in order to find the z-score of the 0.9, and then you have to use a table. So let's go back to the table we have. Okay, so table that we have, Then I'm looking for the area of the 0.9. So when you're looking for the 0.9, close to 0.9, I want to say that is 1 point. This is actually the close enough. Do you see that this number is close to 0.9? Because this is actually a little bigger, right? So I want to say this one. So this is a little bigger, right? So this one is close to 0.9. So z-score is going to be 1.28. So keep that in mind. So this is going to be 1.28. Okay, so we found that. And then we're going to find the x value here. So the formula for the x value was z times sigma plus mu. So in order to find the x, z was 1.28, sigma was 20, and then mu was 200. And then it's about 225.6. So what conclusions we can get? So conclusion is going to be a score of 225.6 should be used for the cutoff. Anyone scoring 225.6 or higher qualifies for the academy. Okay. Number 4, qualifying the test score for this time. So qualifying test score. In order to qualify the medical study, an applicant must systolic blood pressure in the 50% of the middle range. In the systolic blood pressure is normally distributed with a mean of the 120 and standard deviation of the 4. Find the upper lower limit of blood pressure a person must have in order to qualify the study. So mean value was 120, and then standard is 4, so 124, 128, 132, and 116, 112, 108. Okay, so that's just step 1, and then we try to find out about the 50% of the middle range. Okay, so something between. So let's see. So something between. So I want to say about here. I don't know exactly, but about here is, I think so it's a 50%. So this is about 50%. All right. So in step 2, we have to use a technology or table to find the z values. So okay, let's go back to here. So which means if it's a 50%, which means this is actually the 25%, and this is about the 25%. So in order to find the 25%, and we have to find the probability of the z, which is less than one number, will become 0.25. And then the normal distribution is always a symmetric, and then we can find the other z value. So let's use a table. So if you look at the table to find the 0.25, 0.25 is about 25. So I want to say 0.25. This is a 17, and I think this is close enough, right? So this is a negative 0.67, right? I think this is close to 0.25, right? So negative 0.67. So keep that in mind. So in here, I want to say the z-score, it's going to be negative 0.67. right? So one z-score is negative 0.67 and other z-score is going to be 0.67. All right, in the step 2, that you have to say that the z is negative 0.67 and z is 0.67. So in the step 2, step 3, we have to use a formula. Find the x is about, the formula was the z times sigma plus mu. So z was negative 0.67 times by 4 plus 120, which is 117.32. So that's the one value of x, and the other one is positive 0.67 times 4 plus 120, which becomes 122.68. Okay, so if I go back to the original, which means this is about the 117.32, so this is about the 122.68. All right. Okay, then determine the normality. So there is a variety of the ways to determine if the distribution of the value is normally or approximately normally distributed. The easiest way to check for normality is to draw the histogram for the data and check its shape. Another is to find the Pearson coefficient, which is a PC of the skewness of the Pearson's index of the skewness. Okay, so PC equal to 3 times x bar minus median divided by s. So if the index is greater than or equal to positive 1 or less than or equal to the negative 1, and then it can be concluded that the data are significantly skewed. So check the data for outlier by finding the outlier boundary as defined, which is, this is the formula that we just learned earlier. Okay, so all right, let's go to the problem number 5. So in the problem number 5, technology innovations. A survey of the 18 high-tech firms showed that the number of the days inventory they had on hand determined if the data are approximately normally distributed. So I make the histogram already, okay? So it's not the easy to, okay, it's a graph. So I just use the data we have, and then I make the 18 data, and then I make the distribution, the histograms already, okay? So before we're gonna construct the frequency distribution. So I make the table as class was a 5 to 29, 30 to 54. So I make it that way, okay? All right, so if I'm looking for frequency, so number in the data, the value, there's 2 numbers is in the 5 and 29, and 3 numbers 30, 54. 4 numbers 55, 79. 5 numbers 80, 104. 2 numbers 105, 129, and 130 and 151, and then 151 and 7 there's a 1, 2. So we can use the formula for the Pearson coefficient of the skewness to determine if there is an indication is the distribution is significantly skewed. So I'm using the PC of 3 of x bar minus median divided by s, which is 3 times of mean is adding all the data value together and divide by 18, and then you get the 79.5. And then median, which is median is you gotta put the number in the ascending, which is that is, and then find the middle number, and then which is the middle number will be the, is it 74 and 81? So 74, 81 and divide by 2. 74 plus 81 and divide by 2. And then you get the 77.5. And divide by s, which is, there's a formula for the s too, right? So if you find the s, it becomes a 40.454, which becomes 0.14a. So this is actually the the between the negative 1 and 1. So we want to say that, oh, excuse me, because 148, so because of that, this does not indicate significant skewness, which means we can just consider as a normal distribution. So check for the outlier. If there's an outlier, so outliers, we gotta use the formula, which is a lower bound Q1 minus 1.5 times IQR, which is a Q1 is a 45. So I showed you this one on the previous chapters, right? So please find it and do this, and then you get the negative 34.5, and then upper bound Q3 plus 1.5 times IQR, which is a 45 plus 1.5 times 53, which is gonna be the 177.5, because IQR is gonna be the 98 minus 45 as a Q3 subtract Q1, which is a 53. So if you take a look, yeah, no other number is greater than 177.5, and then there's no less number than negative 34.5. So there is no outlier. Which means for the using these three indicators that the distribution is approximately normally distributed. All right, let's look at the next question. So next question is the number of the runs made. The data represent the number of the run made each year during the Bill Mazeroski's career. Check for the normalcy. So 30, 59, so those are stepped out, okay? So I make the class as 0 to 9, 10 to 19, like that. All right, so I need you to see how many we have here. So as 0 to 9, there's a 1. And then the 10 to 19, there's a 2. And then 20 to 29, which is 1. And then 30 to 39. 30 to 39 is going to be there's a 1 and 2. And then 40 to 49, which is there's a 1. And then 50 to 59, which is 50, 59, so 1, 2, 3, 4, 5, 6. And then 60 to 69, which is 3. And then 70 to 79 is a 1. Okay, so yep, that's what I got. And then if you put the histogram, yeah, it doesn't look like a normal distribution, right? I don't think it looks like a symmetric to me. So use the Pearson coefficient test. So 3 of x bar minus median divided by s is 3 of 45.235 subtract 52 and divide by 20.584, which is negative 0.986. So I'm going to say this value is close to negative 1. So the coefficient indicates significant skewness. So I want to say it's a left skewed. Okay, do you see that here, right? Okay, so but let's find out the outlier. So check for outlier. So lower bound, which is Q1 minus 1.5, inner quartile range, which is 29.5 minus 1.5 times 31, which is negative 17. And upper bound Q3 plus 1.5 times IQR, which is 60.5 plus 1.5 times 31, which is 107. So where the IQR is Q3 minus Q1, which is 60.5 minus 29.5 become 31. So there are still no outlier. So there are no outlier. But still the distribution does not appear to be the normally distributed, because it's kind of left skewed, which is a positive skewed. Okay. Okay. Alrighty. Okay. That's all. Thank you for listening.